All been having a good Defcon? Man, come on, how can you not have fun here? Well, that's true, but... Oh, yeah, and one of the goons has an announcement, so...
I've been asked to tell everybody that DT is in the dunk tank. DT is in the dunk tank, so if you would like to dunk him, he will be there. But unfortunately, you'll have to miss this talk, and from the look of the room, you probably don't want to miss this talk, so I did my job, now you can have fun.
Awesome, thank you. What are you talking about, Taylor? No. Okay, just so everyone knows, I'm Lin0xx. I run a site with a friend of mine called noxfiles.com. It's basically a security research type of thing, and the first presentation released by us is about advanced Windows-based firewall subversion. So this is not going to be just, oh yeah, run it over port 80, the firewall won't notice, hopefully, type of thing. This is a lot more technical than that. There will be a lot of reverse engineering and payload development, all that fun stuff. So get ready. All right. Okay, first of all, a little background. There's a prevailing mentality throughout all of InfoSec and the corporate world that, applications aren't secure, so we pretty much need to develop something to cover up for someone else's vulnerability. And many people believe that a firewall, an HIPS, I guess you could use the terms interchangeably to an extent, but they're HIPS and personal firewall kind of do a little bit of a different thing. Well, they do the same thing, but in a different way. So, but there's one small problem. If we manage to exploit one of these vulnerable systems, we still have execution control. We still can do whatever the user running at that, whoever owns the process can. And attempts to stop us can be broken. It may be a little bit difficult, but they can be done. Now, some former research in this area, I just wanted to cite FRAC 62 number 13, article 13 in there. It presents some standard methods for bypassing Windows-based personal firewalls. Now, what it mostly involves is injection of code into a trusted process. But as you'll see later, a lot of firewalls will detect this type of thing. It's kind of, if I recall, this issue is kind of old, but it's still good code, so I do recommend you all check it out. It presents some different methods of doing it, and yeah, it is pretty good research. Now, there's another thing on this about why more research is needed in this field. Why is it important? These personal firewalls, these HIPS-like systems, are getting more and more common. They're pretty much moving to a point where firewalls, antivirus systems, and anti-spyware crap is going to be all in one product. Just one thing, not a suite. And not to mention, you have a whole lot more file format bugs these days, like just the WMF exploit, the Excel spreadsheet vulnerabilities that we've seen in, I guess, the past month or two. And in an application like Word, it's kind of going to look funny if Word is trying to bind to a port. Now, maybe we want to get past that and not let the user know that that's happening, or just be able to break out in general. Basically, we have to start breaking out of the cage, right? I haven't seen too many exploit frameworks or anything do this type of research, these type of payloads, or anything like that. It's kind of disappointing, but that's why we have this talk. So the tools needed to do this. Basically, you need a debugger. OllyDbg is my choice. Many people prefer WinDbg. That's fine. A disassembler, not totally necessary if you have a debugger, but IDA Pro is a good choice for this. And an assembler. I prefer NASM, and that's what the Metasploit payload development kit uses, so I guess why not. And you're going to need a compiler also. And I chose Microsoft Visual Studio C++ 2005, and the Express version works, and it's free. So you know what? You can go home and compile my code and run it, if it works on your system, and I'll cover that later. So the first firewall that we're going to go after is the Windows firewall. Service Pack 2 has brought us a, well, more improved firewall than the first one, but you know, it's integrated into Windows and offers a little bit more control than the original. But there's a really big problem with this. Now, let me see. I'm going to bring up the MSDN library. I have it on my system here. So let's search for a little string here. Exercising the Windows firewall. All right, let's just see what this comes up with. Okay, let's see what this, using the Windows Firewall API, exercising the Windows Firewall. Let's see what that does. Now, if my system would be fast, but okay. Now, Windows Firewall initialize. Let's see if we get something interesting here. Windows Firewall is on. Turn on. Oh, and here's something funny. Windows Firewall turn off. Looks like it might do something that maybe people don't want it to do. So, as you can see here, Microsoft has provided a full API, or it's through a COM interface that allows you to do all sorts of fun stuff. So you can do things like enabling a service, basically allowing one application out, or, you know, here's my favorite method, put firewall enabled. Yeah, so you can just put firewall enabled, variant false, and what do you think that does? So it can, arbitrarily authorize applications to basically, be allowed out through the firewall. And basically, the shellcode here will basically initialize a COM object. Let me see if I can get the code up here so you can all see the C code that I wrote. Okay, I think it's an FW killer. To remember which one this was because the C code is not as important as the actual assembly payload. Okay. So basically, what you're going to do is initialize COM via co-initialize X, and then you're going to initialize a COM object, which I believe is FW manager, and then that has a method called getLocalPolicy, and that FW policy also has a method called getCurrentProfile, which basically, that contains a method called putFirewallEnabled, and we just set it to variant false, and that works. Sounds kind of funny, doesn't it? I mean, this shouldn't be that easy, in my opinion. Now, granted, you do have to run this as an admin to get it to work, but there are a lot of ways to escalate your privileges inside of any operating system. You know, hard on the outside, somewhat more mushy on the middle. So, demos, they're important. If you don't do them, people look at you like you don't know anything, so that, all right. Basically, I wrote up a payload for the Metasploit framework.
Can you bring the window just to the right of the stage so we can see it?
Yes. Sorry. Okay, great. You're all able to see that fairly well. I'm not sure if I can get the font any bigger on this because it's in a virtual machine. But the bottom line, who all knows what the Metasploit framework is? All right, a good number of you. Just for those who don't know, the Metasploit framework provides an automated way to create and test exploits along with developing payloads for them. And just so happens the developing payloads is kind of what I was doing here. So it proved to be quite useful. All right. Now I'm just going to bring up the Metasploit console here, if it will load. Now there's a new version that's written in Ruby. I didn't have too much luck getting this payload to work with that. There are just some kind of there must have been some kind of quirks in there. HD had been fixing some stuff, and I hear it's there are a lot of the bugs taken out of the Ruby version, which is 3.0. But it seemed that 2.6 was the one that I had the most luck with, so that's what I'm going to stick with. Now to deliver this payload, The exploit that I'm going to use is the WMF exploit. And why this is important is if you think about it, there are a lot more cross-site scripting attacks are happening these days. You know, redirecting the user to, you know, some other arbitrary site, you know, getting data. You know, you have all this AJAX stuff where, you know, basically you're able to funnel data in without the user knowing, fun stuff like that. If you all had seen Billy Hoffman's talk at Black Hat about that, that'd be a little bit more informative on this subject. But cross-site scripting is a lot bigger, and you have a lot of L users who have the tendency to click on any link if it kind of looks like it's trustworthy, even though it has like a script tag at the end and it says, I pwned you. I don't know, maybe that's just me. Okay, and I'll set the payload. This is a bind payload, by the way, to demonstrate the fact that it seems that the Windows ICF is very tuned to basically blocking applications from binding. It doesn't do as much against stuff connecting out. But the reason that it's important to be able to disable this is what it will do is prevent you from accessing a lot of network resources. Now, if you want to be able to break into one system and own all the boxes on the network, you will want to be able to do that. And, you know, through SMB, you know, be able to browse the shares, all that fun stuff. So it is an important thing to be able to do. Okay, and exploit. So now we have a bind handler. Well, it's not a bind handler. It's basically a makeshift HTTP server. And in fact, the 2.6 can't actually shovel a shell on this, but so what I just did is, you know, use netcat like normal to gain that. Okay, that's 28.128. Yeah. That's the default port that I'll be running on. So, okay, now let's see how usable this VM is, because the screen resolution got kind of mangled in this whole process of setting it up. Now, okay, first of all, go to the control panel, see if the firewall is actually enabled here. And scroll up a little bit. Yep, it's on. So, and I'm just going to leave don't allow exceptions off because it really doesn't matter in this case. So I'll go here, and I believe it was. I believe that was 128. All right. Yeah, so okay, so it's going in. Now, you should see an image pop up here. Now, oh, fun. Do I want to keep blocking this? Okay. Now, I wonder if I had set the payload correctly, because it shouldn't do that. But to be fair, this is why I have flash demos of this stuff, because all right, yeah. Sorry about this. I just figured that there would probably be some screw up during this, but you will be able to see how truly powerful Windows XP Firewall foo is. Okay. Oh, man. God. All right. So let's see here. Can you read that at all? Now, you basically get a general outline of what's going on. So as you can see, I'm enabling the firewall right there. And then, okay, go back to my terminal on my Linux system. And I'm launching the MSF console program right there. So basically, I'm doing the same thing that I was before, but this time it will work. So, gotta love live demos. Now I'm just entering the exploit to use right here. Excuse me? Yes, and the main reason I did that was basically the way you know that this is working is if you do a bind one and you don't get that message that you saw on the other part. Now, I don't know, it was an act of God or something. I must have done something really bad last night, but, okay, now why is that running so slow? All right, well, hopefully it'll get a bit faster here. Again, gotta love live demos. So let me see. A lot of disk activity because I have this virtual machine stuff running. And all right, I think I need to like close some things here, like the MSD and library. That needs to go. Oh, fun! My system got locked up. Windows is exacting its revenge against me. That's. You know, it has a soul and all that, so, you know, you have all sorts of fun stuff going on there. Yeah, close that. Big memory hog. Yeah, very robust, as you can see. Now, oh, okay, now it seems to be running a lot faster, so... Okay, yeah, now doing exploit right there, so it's going to start the HTTP server. And what? Why did you? I just killed you. Good lord. Okay. Now waiting for the connection on, and then we'll go back to the VMware system right here, and then run, and then basically I'm running iExplore and then the URL of that malicious site. So just say some L-user. You know, happen to click on that and some cross-site scripting vulnerability. So basically, it's going to be pushed down. It'll run. And it will say, as you can see, your firewall got disabled. So therefore, if you'll wait for it here, I'm netcatting to the port 444, which is the default port set up in Metasploit for which port to bind to. And we have a shell, as you can see. So it may have said something to the user, but we still owned them. So, I mean, you could basically shovel in your own payload that would, you know, do something like load a rootkit. So, oh, all of a sudden, you know, it doesn't really matter that they know anymore. They're still fucked. So, all right, let's see here if I can. Yeah. Okay, no, just, jeez. Yeah, fun stuff here. Jeez, VMware. Come on, we're supposed to be reliable. Sorry for this, but. All right, let's see. That should be in full screen. Oh, well, now we have this fun up here. So if you can ignore that. Yeah, everything that can go wrong will go wrong, so that's just one of the rules here. So the next firewall that we're going to go after is the ZoneAlarm personal firewall, and this is actually a little bit of an older version compared to the new one, and I will discuss the new one. Now, this is one of the main personal firewalls used. You know, everyone talks about ZoneAlarm all the time. And these personal firewalls have a hard job because they have to defend from threats locally and remotely, aka people like me. So one of the most important components in this firewall is called True Vector. It's basically a driver, and it's basically, you know, the network part of it. And ZoneAlarm is really pretty much a GUI on top of it. This is basically a beneficial rootkit to your system. And it's basically what keeps it safe from all sorts of local threats and what have you. And it's quite aggressive about defending itself, as you will see. So reversing ZoneAlarm. Our plan of attack here, we need to get write access to the zlclient.exe process and inject code into it that will disable the firewall. We need to run that code and make sure it's done quasi-stealthily, so then you don't have all sorts of, you know, flashing buttons come up on the screen and what have you. And I'm going to call it ZaRooter. So first, we have to find the process. we need to find zlclient.exe's PID, process ID. Now first, we'll run enum processes to get a process list and then use open process with the parameter of process query information to be able to basically enumerate through what certain, like the actual name of the executable. So then we'll use enum process modules to get the module handle of the process and get module base name A to get the process name. Then we can just continually string compare this to zlclient.exe, and when we hit that, we'll know that we have the right process. Now there's a big problem here. True vector for us is a pest. As I said before, it behaves like a rootkit. It hooks a lot of system calls, and this is why you cannot just do a terminate process on the firewall. Although I think if you follow the route that I've used to this, you actually can do a terminate process on the firewall, but it's pretty much going to kill all network activity, so you don't want to do that. And that's one of the reasons I took the route that I did. And the most important call that it hooks, at least for us, is NT open process. If that's hooked by ZoneAlarm and it's doing, what it does, preventing us from trying to attach to it, we will not be able to get a handle to zlclient.exe, and our code can't run. We won't be able to inject any code into the process. And that's a very big problem, because how else you're going to shut it off. So enter the ZaRooter driver. Now, the funny thing in this version of ZoneAlarm, TrueVector or ZoneAlarm, whatever is doing it in the back end, does not mind if we load a driver. Ooh, rootkit, hello. So we can write to the system service dispatch table, and we can execute code on the same level as TrueVector. So guess what? We can unhook every system call that it hooked. Yeah. So basically here we have the Pseudo-Rootkit, because it doesn't really do anything malicious other than unhook a system call, and no one's really going to notice that, but actually you can, but it's like for a normal user, even if they got their hands on one of these programs that you can view the syscall table, it's like, oh no, there's one less hook in there, so I'm less vulnerable, something like that. So basically an outline of how this will work. We'll create a memory descriptor list for the system service dispatch table, which is basically using this decal spec right here. Now that's not the most stealthy way to do that, but if you read rootkit.com, you'll find out some other ways to make this a bit more stealthy. And then we'll unhook NT open process and replace it with the address of the original syscall. Well, the original code that ran it. So it turns out that ZoneAlarm didn't actually, rip out the code of that old system call. All it did was redirect it to its own stuff. So it's still there. You just have to find the address of it and use it. So basically, what you'll have to know is you'll have to know the syscall number and the address, and that differs between service packs. And I know my code isn't the most portable after you see what's going on, but you can make it portable. So I'll discuss that later though. And basically we have a macro here that's called hook syscall. Basically takes a syscall number and an address and it'll set it to that. And I can actually bring up the code on here. If my computer doesn't explode, just please pray that it doesn't, because that was kind of odd last time. All right, you go back to, okay. Go to ZaRooter driver here. All this code will be up on the Noxus Files website, by the way, after the con. So, okay, let me see ZaRooter.c. And of course, you have to edit these with Vim, because if you don't use Vim, you're not lead, of course. It's just a rule. But anyway, as you can see, that some of this is kind of messy because I was kind of experimenting about which calls to unhook and what I could do with that, but I basically commented out the ones that don't really matter for our purposes. So you basically have an array of, what the address we want to set the hooked syscall to, and basically an array of syscall numbers that we want to unhook. So basically right here, it will iterate through all of this, and then it will say if you have a debug event viewer on your system, you can actually see, status unhooking syscall number blah with address of, blah. So it'll unhook the syscall and basically will win. So that's the important thing. So now we have to find a way to shut it off. Now this takes some reverse engineering right here. And basically after a while of grinding through code, you find that there's this little function at this hex location right here. And it seems to be a pretty reliable address, so it doesn't change a whole lot, but or at all that I've seen. And basically the funny part is, if you can see TVTF forced shutdown right there, yeah. So anyway, basically if you pass it a value of 4, it will tell true vector basically to screw off and don't do anything. So that's pretty fun. So we can call that via code that we inject into the firewall. Now, if you try to do this, is actual. If I recall correctly, methods that are basically at a lower level than this are in some of the ZoneAlarm DLLs, but don't try to call them because it pretty much won't work. It has some sort of authentication stuff that basically knows whether you're running it actually from the firewall or not. So problem number 2, we have a lot of alerts that are going to pop up. That sucks. We don't want the user to know that we're actually rooting them. So you have icon changes, you have a text box like right here, and you have that nice, message system error, please reboot. Maybe that would, alert people that there is something a little bit wrong, and all that fun stuff. So we basically need to get rid of these. Now, the first one is there's an icon change. As you can see right there, there's a big X, and then it will say true vector security service is shut down. We don't want the user to see that because they might wonder why a big red X is in the bottom of their system. Although with some users these days it may not matter, but we still want to be cautious here and do what we can. So what's kind of funny is shell notify icon basically takes 2 parameters, and one is like the message it's going to send, and this notify icon data structure right here. Now I didn't research into all what that did, but basically the bottom line is it changes the icon and we don't want it to. So we can pretty much replace that call with add ESP8 after it's pushed the parameters, and there is no more call. Because do any of you know how the stack works when calling a function like in assembly language? Anyone? Okay, well the bottom line is things get pushed onto the stack kind of like you stack plates. And the front, where the top plate is, that's where this register called ESP is. And basically, indirectly, it will reference all of the arguments from that. So all this does is pretty much resets that pointer, from the top of the plate or the stack, depending on how you want to think of it, further back. So it pretty much doesn't matter that they had these arguments for it. So basically, we just killed that call. So we win. Now the screen text. It uses a few resource strings in the .rsrc section of the portable executable. For those of you who do not know, the PE is the format, like you have an exe file, you run that, that's PE. So basically, you see all these system error messages and whatnot. Well, we can just overwrite them with our own. Sounds good. So, and it uses draw text to write this to the screen. That's a, I believe, GDI call. If I'm not mistaken, I think it's in user32.dll, but that's kind of not important right now. So what we're going to do is have a user mode hook on draw text. Now, because we want to see whenever it's going to try to spit these nasty messages out. Now, what we're going to have to do first of all is pretty much preserve the program state at that moment. We can use these opcodes right here, push A, push FD, pop A. Basically what that does is it saves the state of all the registers and pushes it onto that stack, the plate thing. So, and then also it does this for a flags register too. And basically that has some info about whether you're going to, jump this way, jump that way. But the bottom line is we're saving the program state. Everyone understand that? Yeah. Okay, good. Now, what we're basically going to do is where you see this move EBX ESP plus 2C after the push add and push FD. That's basically looking at one of the arguments of draw text. So it's basically seeing what text is going to be written, and it will check it for all. Now, I think I forgot to explain the reason why I did this. But if you see here, that's red. System error, please reboot, that's all in red. Now, if you notice when it's running normally, let me see if I have it running in the virtual machine here. Okay. Oh, no. Okay. Oh, that's all right. Yeah, I have that basic reminder there, but you saw it work, so that's important. Wait, that's not going to show it either. I'll just run ZoneAlarm on this. Now, come on. Zone Labs, okay. All right, now if we can wait while this program runs, and it will start up. But the bottom line is it's all in green. So we don't want to have flashing red messages everywhere. That's going to be a problem. Now, I'll come back to that. That's going to take forever to load with the amount of stuff I'm running on this. So basically, we're going to check for all because, you know, that's the message. We want it to say all systems are active. That's pretty much what the original message was. And that's what we did with the overriding in memory. Now, pretty much what it's going to do is if it's there, it's just going to run set text color to set the text to green. And then we basically do the rest of the stack setup, and then we win. Now, there's one issue here. How are you going to transport that driver over to the infected, the exploited user system? Now, one approach here is to include this as a resource in a DLL. Now, the nice thing about the Metasploit framework is that a guy named Scape wrote this little payload that did DLL injection basically over TCP, remote DLL injection. Now, if you've ever seen someone, I don't know, get a remote desktop display after running an exploit through VNC on someone else's box, that's it. That's what it's all about. Basically, you can transport a full program, no assembly language programming required, in a DLL, and they'll run it. Unfortunately, my DLL had some problems with that. Like, it worked in the... Oh, okay, here we are. Allow that. So just to show you again, like with the green text, it's right here. See, all systems active. So, yeah. Sorry, my computer's being a bit schizophrenic, but that's okay. And so what I was talking about is transporting this driver, this malicious, quasi-malicious driver over to the other person's machine. So what we can do is include this as a resource. Like in that .rsrc section that you saw before, we can throw files in that and all sorts of fun stuff. So we can use the find resource function, load resource, and basically write it to the disk to, of course, write it to the disk. And then use the system control manager to load the driver. Now, somehow during this, we're going to have to coerce this program into executing this code. Fortunately, Windows offers some process, I guess you would call it, interaction functions. Basically, the interfaces that you use for writing a debugger are the ones you kind of use here. And come to think of it, what this is really like is, do all of you know what a loader is, like with software piracy? Like if you, if the program is packed and you want it to decrypt itself and then inject the code later, what you can do is write a loader. And so basically it will use write process memory and all this other stuff to basically wait a certain amount of time, inject the code to disable like your serial check or what have you into the process, and then it will be okay. Some of them are more intelligent than others, but it's not that important here because we're not dealing with any obfuscation or encryption. But this shutdown code that I was talking about before, remember if I told you that pass this a parameter before it shuts the firewall off deal, will be, I basically went through the executable and found a whole bunch of slack space to write it into. So it's going to be pretty reliable. We won't have to make it really position independent in this case. Like, because jumps and stuff like that to other memory addresses can be thrown off depending on where you are in memory. So I pretty much picked a static one, and it's worked. So don't question it. So now what we're going to do is run this one function called create remote thread. basically, it does what it says. It creates a remote thread. You basically pass it the starting address of where you want to start your code, and then it'll run it. Sounds fun, doesn't it? I mean, just running code in other applications, God, that's awesome. So we do this after we've changed all the strings and injected the hooks like on draw text and what have you. So we're going to have a demo, and this will hopefully work a lot better than the last one, because I've tested it on here, and by God, you know, it needs to work. But I have a flash demo in case it doesn't, just so you know. Now, what this metserv test thing is it's a program that the Metasploit people use to test their thing called the Meterpreter. How many of you know what the Meterpreter is? Okay, that's a few people, but for those of you who don't know, basically the Metasploit people had this idea to throw something like, to put it in layman's terms, a hacker's command prompt into your system remotely. And it will do this over DLL injection. And to test their payload, of course, what they would do is write a test program to load it. So that's what they did. And basically, I'm too lazy to edit their code, so it will pop up an alert saying that it's binding to a port, and it's completely unnecessary. But it was just for the way they have it set up is you want to be able to actually view what's going on. But with this, it's pretty much a blind shove it in and run. So when it's going to listen on a certain port, as you can see, I've already ran this, so it's listening on port 31337, you know, because of course that's the elite thing to do. And once you connect to that port, however, it'll just run the DLL. So as you can see, this is just a whole test thing. It doesn't really affect the performance of the DLL. So we're going to run this. Okay, start that running. It's going to listen. Yeah, see, like I told you, allow that. Okay, now I will, basically I'm going to do this the ghetto way and pretty much open up a web browser and tell it to go to that port. So we'll run that and it will come up and oh, you got owned. You know, gonna have a message box there. So that'll run two times, and so then, oh, look at that. Your firewall just got disabled. And guess what? Doesn't really say much about it, here about what just happened. It's kind of fun, isn't it? And in fact, one fun thing is that if you're waiting for like, say you want to ping someone, right? And you run the ping command, and then it will say, you know, allow or disallow this traffic. If you run this, that alert will stay up, but it won't matter. So the user is like, oh, I'm going to be, you know, the big man out, you know, click deny. Well, it's not really going to do anything. So that was the demo there. So I didn't include like getting a shell on it, but I'm sure all of you, the bright minds out here can figure out how that works. So I went in after we've basically reversed these two firewalls and done some pretty, you know, technical, in-depth methods of breaking them, right? So I tested some other firewalls, you know, with basically some general tests. If we could inject code into another process and have it run, I did this in a very ghetto fashion. What I basically did is opened up Internet Explorer and OllyDBG, used a Metasploit payload generation program to generate a payload, and with some said magic, I could extract it and paste the payload in. So it would just, you know, basically run the shellcode, but yeah. So it'll test for that, and also the ability to debug the main firewall process. Obviously, as you saw in this, if you can debug the main firewall process, you pretty much owned it. So, and also whether syscalls were hooked in an obvious manner, basically because the whole idea is that if they were, then you could use the same driver that I wrote to unhook them. So, and yeah, basically the ability to load drivers too, because that's important. You know, you don't want rootkits to be able to be loaded on your system. Wait, I forgot to change it. Okay, so the first one we're going to talk about is Cario. Now the main process can be debugged, so it kind of, I haven't done any actual like, I'm going to turn this off and here's the DLL for it like I did for ZoneAlarm. But if the main process can be debugged, it's safe to assume that we can turn it off, okay? So, but to its credit, it does detect code injection into trusted processes, but it didn't seem to detect a driver load either, so yeah. Comodo. This is another popular firewall I've seen, and the main process cannot be debugged. It has non-obvious hooking methods, and it also detected code injection into a trusted process. But here's the kicker, it didn't seem to be able to detect a driver load. So, and the latest ZoneAlarm Pro, and actually, this is the latest version, and it's learned its ways from my previous DLL. It does detect code injection into a trusted process. You cannot debug the main firewall process, and it does detect driver loads, and that's one of the few, if only, firewalls I've seen that does that. So props to ZoneAlarm for doing this, implementing this mechanism. But it does seem to have the same hooking mechanism as before. So the idea is if you're able to get kernel mode code execution, you can still disable it pretty simply. So now let me go back here just a minute. And what more needs to be done? Okay. Oh, I was supposed to talk about that after ZoneAlarm. I'm sorry. But the thing with my ZoneAlarm payload or DLL is basically that it really needs more portability to it. If you run this between different service packs or patch levels even, it'll blue screen. Because it would basically tell, that the hook on NT open process to jump into an area of memory that, well, it didn't have the right code at it because it changed. So, and it needs to be able to have basically more dynamic resolving of the functions that are used, like that set text color, because if you run it as is now, you can have basically jump errors. I didn't do any arithmetic on calculating jump offsets and whatnot, so that's going to break your program. And more intelligent generation of the jump hook that was placed on draw text, so we could, make it green and whatnot. Okay, so conclusion. Things to be learned here. Firewalls are just applications, and they're not really the end-all of security. Somehow, some way, you're going to be able to break it. And subverting them will only increase in importance later, because more and more people are going to be running it, more and more people are going to be dependent on it. You have Vista that has HIPS-like features in it as well, so you're going to have some more code that's going to come out for that by various researchers. And so pretty much this is the end of the speech, but thanks to HD Moore, who helped me write the Windows Firewall Disabling Payload. Poncho, of course, helped me with the Noxus Files website, and Optics. I know you're not here, but thanks anyway. You've had some great insight to stuff. So if you want, the code should be up at noxusfiles.com later in the day, like about an hour or two. So get the code, play around with it, test it out, everything like that. So that's the end. Any questions? Any questions? Yeah, and use the mic, please.
I have a question.
Yes,
I saw
Ducky?
how you were. I'm sorry, I'm not that person. With disabling all the alerts and stuff, what about the actual disabling the Windows alerts, the balloon
Yes.
pop-ups?
This that is done via the WMI interface, and I imagine that if I took a look and saw actually what that did, I would be able to kill it, because I know there have to be API calls for doing this. Mm-hmm. Yeah, for anyone who knows about that type of thing, feel free to download the code, implement that, and then contribute to it. So that's my charge for you guys.
Thank you.
Yes.
The Symantec firewall, did you experiment with that?
No, I did not. I basically took those 3 firewalls. I kind of added that in at the last minute, so I didn't have the chance to get actual, firewalls that costed stuff. So, yeah, because of course no one wants to pirate here, right? Just saying. Yeah. Next question?
I'm curious on the on your experience and what you found for disabling the firewall and getting at people, since they're probably behind NAT versus just doing reverse shell.
Well, there are. What was the question again? But behind a NAT? I mean, if you were doing a reverse shell or reverse interpreter, pretty much that would subvert the NAT now, wouldn't it?
Yeah.
Yeah. So, but the reason, are you wondering about the bind that I did with the XP firewall?
Yes.
That was basically to show, because the Windows XP firewall, it pretty much blocks the bind. That's what it's most concerned with more than anything else. And so by having you be able to get a bind shell, that shows for certain that it was disabled. So that was basically a proof of concept right there.
Okay.
Thank you.
I was just curious to see if this presentation was on the Defcon CD.
Yes, it is.
Awesome.
There,
You rock.
the last slides, I think about the other personal firewalls on there that I kind of smoke tested a little bit are not, but I mean, that's not the most important thing in the world, but you'll be able to download them from noxusfiles.com. So
Sweet. You
yep.
rock.
Thank you. Any other questions? No, I'm currently not wearing pants. Yeah. Yeah, so all right. Hope you've had a great DEF CON and will continue having a great DEF CON. Thanks for coming.